Good day, students. In this clip, we're going to be going over some examples on how to find the derivatives using the limit definition, also known as the symmetric difference quotient. Okay, so let's go ahead and write down the instruction for the examples. So for the following examples, we're going to use f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So we're going to use this to find the derivative of the given functions. Okay. All right. So the first example we're going to consider is a function f of x equals 7 over x squared plus 6. All right. Now, before I pull everything together, I'm going to first of all determine what f of x plus h is, and then f of x we already have, and then we'll pull them together and then simplify our expression, okay? So if this is f of x, then what is f of x plus h? F of x plus h is a function you get when you replace x with x plus h, okay? So instead of 7 over x squared plus 6, it's going to become x plus h squared plus 6. Okay, this is a composite function, so that's what you have. All right, so let's go ahead and simplify this denominator as much as we can. So we're going to have 7 over x plus h times x plus h plus 6. And then if you simplify the two uh, binomials that we're multiplying here, you're going to get x squared plus 2xh plus h squared plus 6. Okay? Now we have f of x and f of x plus h. These two terms determine the numerator of this symmetric difference quotient right here. So let's pull everything together. The derivative f prime of x is going to be the limit as h approaches 0 of f of x plus h, which is 7 over x squared plus 2xh plus h squared plus 6. So that minus f of x, which is 7 over x squared plus 6. And then this entire, these two expressions right here divided by h, because that's what's in the denominator of the limit definition of a derivative, all right? So let's add these two as though we're adding a fraction, so we need to find LCD. We can multiply um, this denominator with this numerator, and then this denominator with this numerator here. So this um, this piece right here, I'm going to multiply by x squared plus 2xh plus h squared plus 6. So to preserve equality, whatever you do on the top, you do the same on the bottom. X squared plus 2xh plus h squared plus 6. And then on the left side here, the denominator here is x squared plus 6. I'm going to multiply top and bottom by x squared plus 6. And then in the bottom, put that in here, x squared plus 6. Okay? All right, now we have to simplify as much as we can completely. So this 7, I'll distribute it to this 6 and the x squared. And then on the right side here, we have a negative 7. So I'm going to distribute this 7 to all these terms right here. And then the denominator, I'm going to do double distribution, all right? So let's start with the numerator. So in the numerator, I'm going to have the limit as h approaches 0. Now if I distribute that, I'm going to have 7x squared plus 42. Now let's do this distribution here. Minus 7x squared minus 14xh minus 7h squared minus 42. Okay, that's what you get in the numerator. Notice I was distributing the negative and the number together. That's all the signs changed. Now let's shift our attention to the denominator and the numerator. I'm going to distribute the x squares first. So I'm going to multiply. Since these two quantities are exactly the same, I just focus my attention on one. So when I distribute x squared to everything here, I'm going to have x to the fourth, and the next one plus um, 2x to the third h, x to the third h, plus 2x plus x squared h squared plus 6x squared. Okay? That's, well, this is what I get after distributing x squared to all these four terms in this parenthesis right here. Okay? Now I'm going to distribute 6 to every term in this parenthesis. So let's go ahead and do that. So I'm going to have um, 6x squared. This is similar to this, so I can line it up here. Plus 6x squared. And then 6 times that is plus 12xh. And then distribute the next one plus 6h squared plus 36. All right? Okay, now let's simplify. Oh, wait, let's not forget the denominator is also h divided by h. Okay? All right. Now, moving along, let's simplify the numerator. If you take a look at the numerator, you notice that we have an opposite here. 7x squares cancel out, and also the 42's cancel out. All right? So now let's simplify further. We're going to have in the numerator, let's write the limit as h approaches 0 of negative 14x h minus 7h squared. That divided by, and then let's simplify the denominator a little bit. If I simplify the denominator, I'm going to get, let's see, I can combine like terms here. So this term x to the fourth plus 2x to the third h plus x squared h squared. Now 6 plus 6 is 12, right? Plus 12x squared plus 12xh plus 6h squared plus 36. Okay, now this I'm dividing by h, so I can write this h as h over 1, and then I can multiply, instead of dividing by h over 1, I can multiply by its reciprocal, which is 1 over h. Okay, so dividing by h is the same thing as multiplying by its reciprocal, which is 1 over h. All right, now let's factor out a common term out of this numerator here and see if we can start evaluating the limit as h goes to 0. So I can factor out, what can I factor out here? I can factor out negative 7h. Okay, so if I factor out negative 7h, I'm going to be left with 2x plus h. Okay, that's for the top. And the denominator basically stays the same. The denominator is still going to be x to the fourth, let's put this up a little bit, x to the fourth plus 2x to the third h plus x squared h squared plus 12x squared plus 12xh plus 6h squared plus 36. Okay, now multiplying by 1 over h, or dividing by h is the same thing as that. Now you can see that this h and this h can divide out. H goes here 1, h goes there 1. Now let's go ahead and evaluate the limits. What I'm going to do is put in zeros for all the h's, okay? So I put in 0 here, this h goes to 0. And then this whole term right here goes to 0 because of that h component, and this goes to 0. This stays because it doesn't have an h. And h, this goes to 0, and this one goes to 0 as a result of putting in the zeros into all the h's, okay? So if I do that, this whole term is now going to become negative 7 times 2, which is negative 14x, all right, divided by x to the fourth plus 12x squared plus 36, okay? And then we can factor this. This is simply a difference of squares, so we can factor that as, I'm sorry, this is a perfect square trinomial, not a difference of squares. It's a perfect square trinomial, so I can factor this easily. I just take the square root of the first and the last and bring down the middle sign. So if I factor this, it's going to be x squared plus the square root of the last one, 6 quantity square. Okay, so that's basically what the derivative is. So f prime of x is 14x, negative 14x over x squared plus 6 quantity square. Okay, if you've forgotten how to do this, you think about your perfect square trinomials. If it's of the form a squared plus 2ab plus b squared, and remember the factored form, you just read the first and the last, and then bring down the middle sign, and then your factored form is going to be a plus b quantity square. So that's exactly what I did here. In this case, a is x squared, and then b is 6. Okay, so you just read the first and the last, bring down the middle sign, and that's the factored form of the denominator. If you don't remember this method, then you can use the AC method. You make your x game, and then you just factor out the whole expression, all right? So this is basically what the derivative of the function is using the um, limit definition of a derivative. All right. All right, so for number 2, we're going to use, consider another function. Number 2, the function under consideration involves a radical. We have f of x equals the square root of 7x. So we're using exactly the same definition, okay? Limit definition. So let's see. We know that f prime of x, let's rewrite the formula again just to refresh our memory, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Okay? All right. We already know what f of x is. F of x is root 7 x. And that tells us that f of x plus h is what you get when you substitute x plus h for x. So it's going to be the square root of 7 times x plus h. And then when you simplify it further, you have the square root of 7x plus 7h. Okay? Now that we have f of x and f of x plus h, we're going to piece them together and input it into the symmetric difference quotient, or the limit definition of a derivative. So limit as h approaches 0 of the square root of 7x plus 7h minus f of x, which is the square root of 7x, that divided by h. Okay? Alright, now what I'm going to do to simplify this radical is multiply by the conjugate, okay? But the conjugate is what you get when you switch this, invert the sign of the sign between the two radicals, alright? So we have a minus in between them, so the conjugate is simply going to be the square root of 7x plus 7h. This sign becomes a plus, the square root of 7x. In the numerator, and then you have to, in order not to change the problem, you have to multiply by exactly the same thing in the denominator also, okay? So multiply that in the numerator, and in the denominator you also have to multiply the square root of 7x plus 7h plus the square root of 7x. Alright, when you distribute the top, you have a difference of squares, right? So remember, if you have let's use a different color here. If you have a plus b, let's do a minus b times a plus b. What is it going to be? If you follow this out, the middle terms cancel out, so you'll be left with a squared minus b squared. This is the factored form of a difference of squares. This is the factored form of a difference of squares, so when we distribute it out, it's simply going to be, we have a limit as h approaches 0. The square root of 7x plus h plus 7h quantity squared, because this is like your a, okay? This is like your a minus b, and then you have an a plus b here. So if you distribute this 2 completely, you're gonna end up with a squared minus b squared. Okay, so this is your a squared, And then your b squared is going to be minus, because b is root 7x, so b squared is going to be root 7x quantity squared. Alright? And then in the denominator, we don't have to do any work. Just leave it like that, because h is already nicely factored out. So we have h times the square root of 7x plus 7h plus the square root of 7x. Okay? Now if we simplify the top, the square and the square roots cancel out. So we're going to have the limit as h approaches 0 of 7x plus 7h. On the right side, the square and the square root cancel out, minus 7x over, and in the denominator, still a bit along like that, h times the square root of 7x plus 7h plus square root of 7x. Okay, so in the numerator, these two are opposite, so they add up to 0. And then you see this h right here can be reduced with that h over there. Alright, so doing that reduction, we're going to end up with the limit as h approaches 0. Let's put a 1 here, so this is 1, so we don't get confused, of 7 divided by, now that h is gone, we just left with the square root of 7x plus 7h minus the square root of 7x. Now when h goes to 0, this term becomes 0. Okay? So it's going to become, plugging in the limit, the value that the limit is approaching, it's going to be the square root of 7x. 0 times 7 is 0 plus 0 minus the square root of 7x. So we have 7 over root 7x. Okay, this is a plus right here, so this is supposed to be plus root 7x. So look at these two radicals as y plus y. What is y plus y? Is 2y, right? So imagine as though there's a 1 here and there's a 1 here. So when you combine these two, you're going to have, it's going to be 7 over 2 root 7x. Okay, what are we looking for? We're looking for f prime of x. Now we have a radical in the denominator, so we can simplify a little bit further. We multiply by the conjugate, which is 7x, and we rationalize the denominator. That's what we're doing, not conjugate. So rationalize the denominator using the radical component of the denominator. So if you do that, you're going to end up with 7 root 7x, and in the denominator 2 times root 7x times root 7x is so because the squares cancel out, it becomes 7x. Okay? So the root 7x times root 7x is like root 7x squared. So the square and the square roots cancel out, so you have this. Alright, so the 7 divides that with that 7, and then your final answer is the square root of 7x over 2x. Okay? So that's what the derivative of the function is. Alright, so for the next example, we're actually going to use a different definition, an alternate definition. It's also a limit definition, but it's known as the alternate limit definition. So for number 3, we're going to use f prime of x equals the limit as t approaches x of f of t minus f of x over t minus x. Okay, this is another limit definition of a derivative. All right, so we're going to use this to find the derivative of the function f of x equals 2x over x plus 1. Okay. Alright, so to do this, we already know what f of x is. We need to find out what f of t is. F of t is what you get when you input t for the x's, if you substitute t for the x's in the function. Okay, so instead of 2x, you have 2t. Over the denominators of x plus 1, you have t plus 1. Okay? Alright, now let's input f of x and f of t in the formula. Simplify it and see what we get. Alright, so the derivative, which is what we're looking for, f prime of x, equals the limit as t approaches x. F of t is 2t over t plus 1 minus f of x, which is 2x over x plus 1. And then all that divided by the denominator, which is t minus x. Okay, t minus x. Okay, now this is like two fractions that we want to add, so we need to find the LCD. The LCD of t plus 1 and x minus 1 is t plus 1 times x minus 1. So to make the denominators the same, I'll just multiply this by t plus 1 on the numerator and denominator. And then on the left side, I'll multiply by x plus 1, top and bottom. Alright, and then we'll just basically distribute the top and then simplify the numerators, okay? Alright, so you distribute 2t to these two terms here. And then over here, negative 2x, I'll distribute to t and 1. Alright, so let's see what that gives us. We have the limit as t approaches x of 2tx minus 2t minus 2tx minus 2x. Okay, that's what you get when you distribute the numerator. Okay, and that whole thing divided by t minus x. But I'm going to write t minus x as a fractions. Wait a minute. Oh, I'm sorry. So the denominator is x plus 1 times t plus 1. Alright, I left out the denominator and the numerator. So there goes the denominator of the numerator. And then the whole thing now divided by t minus x. Alright, so how about I write t minus x as a fraction? How about I write it as t minus x over 1? T minus x over 1. Okay? Alright, so now let's simplify the numerator a little bit. So we see that we have two opposites here. We can cancel out the 2t, the 2tx. Alright, so we have that. So when I distributed this, I had 2tx and then that, so this is supposed to be a plus. Sorry about that, because this is plus 1 times 2t is plus 2t. Alright. Okay, now moving along, this now becomes the limit as t approaches x of, this we have cancelled out, so we have 2t. Since there's 2t minus 2x, I can factor out, why don't we just factor out a 2 from both terms while we add it, so we don't keep writing the same thing over and over again. So I factor out a 2 out of these two terms that are left here, this and this. If I factor out a 2, I'll be left with t minus x, alright? And then that divided by x plus 1 times t plus 1. And then you see this denominator right here, if you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. So if I multiply this expression by the reciprocal of this, is equivalent to dividing by this. Okay, so I'll reciprocate that and express it as a product, minus t minus x, 1 over t minus x. Alright, so these two match, so they can divide out. They divide out. Okay, so now we're going to have the limit as t approaches x of 2 over x plus 1 times t plus 1. Alright, so what I'm going to do now is go ahead and evaluate the limits. Anyway, I have x, I can replace it with t. Anyway, I have t, I replace it with x because t is going to x. So it's going to become 2 over x plus 1. Now this t, I'll replace it with x because that's what t is approaching, over x plus 1. So that becomes, we can condense it into 2 over x plus 1 quantity square. Alright, so our derivative f prime of x is equal to 2 over x plus 1 quantity square. Okay, so there you have it. Alright, let's just box that because the final answer. Okay, So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. More clips can be found on microserve.com. And please post a comments to let me know what you think about this presentation. Have a wonderful day.